Hey everyone. Don't know what happened this morning, but here's my second attempt at a video for today. So one of the things that we talked about in class to kind of briefly get into the idea of an equation for a circle, and yes, you can write an equation for a circle, is to kind of think about something else that we've done in the past. So you may recall from Algebra 1 that we looked at shapes that look like this, right, and like this. Okay, the first one being something along the lines of y equals x squared, and something for the second one being more like x equals y squared, right? So you have this x and y squared idea that are, or functions, relationships that are quadratics or parabolas in shape. And so if you can think about, and this is very vague, so this is clearly not the case. When we get into this, you'll see. But if you combine those two, right, so let's just say, rather than me drawing it like that, let's just say I combine those two and I kind of move them together so that they overlap. You can kind of see this little circle that develops from that overlapping period. So that's what kind of helps me remember the formula for this, is that I had an x squared and a y squared parabola, and if you put them together, it kind of seems the same way, because the equation for a circle is x minus h squared and y minus k squared equals r squared. So you have this like x squared component, this y squared component, and then this r squared component, right? Okay, so this is the parent function. All right. Now, the h and k are important because they tell us something very specific. They are actually the center of the circle. So they're h and k right there. All right, so in class today, we did a little exploration, and so I thought I would kind of do it for you here so you can see. When you type in that equation into Canvas or into Desmos, and you click all, right, it populates these sliders. Well, what these sliders are numbers that are input for those letters, so the H, K, and the R that you're not used to seeing. But what's nice about them is that they show you exactly how they affect the circle that we graphed, okay? So you can see if I put them all at 0, or as close as I can to them, okay, then all I have is a point, right at the origin. But if I go ahead and move this in and out, you can see how it affects the circle. So the R, as you can tell, changes the shape or the size of the circle, which of course is the radius. Okay, so if I click this down to an even number, hopefully, oh my goodness, stop doing that. Let's try this again. Can I get to 4? Oh, every time I go to take it off there, it jumps. But you get the point. So the radius here, 0, 4.1, right, because that's what that is. The h, in the meantime, if I hit this play button, you can see, okay, the h actually moves that circle left and right. So as I change the h, so does the circle. Same thing with the k. So as I shift the k on the slider set, it moves it up and down. Okay? So you can obviously do this in Desmos. We did it today as well. It's pretty cool because, like I said, it does show the actual shape of the circle and how that equation really works. So we're going to go through some examples. You'll have an exit ticket as well. The first example here says, write the equation of the circle shown below in standard form. All right, so the important pieces, again, are what's the center, because the center is going to be HK, and then what's the radius. So in this case, my center is right here at 0, 0. And my radius is 2. So I'm going to plug that in. So I have x minus 0 and y minus 0 equals my radius, which is 2 squared. Okay, so this is my h and k, and this is my radius. So my center, my radius. Okay, now, again, notice the equation itself has negative signs in there. So even if I go back to Desmos and look, even if it says that this is at 0 or whatever, if this says 5, like h is 5, then I would be shifting to the right 5. But think about this equation up here, okay, it says minus h. So if I plug in a 5, it's going to be x minus 5, and that shifts it right. So what's inside the parentheses is opposite of what you'd think it to be. Now I'm going to simplify this equation in example 1. Anything minus 0 is just itself. Same thing for y, and 2 squared is, of course, 4. So there's our equation for that one. All right, example 2 gives us another point with the center. It's supposed to say with the center at 0, -5, and the radius is 3.7. So my center is my HK, and then this is my radius. So I'm going to plug those in. So I have x minus 0 quantity squared plus y, and this is a -5, so I'm going to change it to a positive inside the parentheses, equals 3.7 squared. Okay, so again, if we simplify this, x squared plus y plus 5 squared equals, and I think this is 13.69 if I remember from earlier. Okay, and there's your formula. So pretty simple. Find your circle or your center, find your radius, plug it into the equation. All right, we're going to write it another one here based on this graph here beside us. It says the point -3, 4 is on the circle with the center of -1, 2. So this is H and K. All right, but this one's a little bit more difficult because it does not give us an even radius, right? You can see it stops short here of 3, or of 2, I'm sorry. Well, it would be 3 with the radius. Okay, so when that happens, you actually have to find the distance of that radius in a different way. Well, one of the ways is, if you recall, from the center of a circle to the outside is always the radius. Okay, so in this case, we can actually draw a little right triangle that has a side length of 2 and another side length of 2, and that's going to allow us to find the radius. Now, you could use Pythagorean theorem, so a squared plus b squared equals c squared, and find the radius here. Or you could recall that this is a 90-degree angle, and since these two sides are congruent, that makes this a 45-90 triangle. So in a 45-90 triangle, so 45, we talked about these before. It's a special right triangle where if the legs are x, then the hypotenuse is x radical 2. So in this case, our radius is our leg, which is 2, times radical 2. Okay? So now since we have our center and we have our radius, we can just use the formula. X plus 1 squared plus y minus 2 squared equals, I'm going to shrink this here a little bit, equals 2 radical 2 squared. Okay, and again, as I simplify this, radical 2 squared is 4 times, or I'm sorry, 2 squared. 2 squared is 4. And radical 2 squared is just 2, because it would be radical 2 times radical 2, which is just radical 4, which is 2. So remember that any number, any radical times itself, is just the number that's underneath the radical symbol. So this would be 4 times 2. Okay, so again, simplifying my answer as far as possible. There we go. There's our answer. Okay, so that's the equation for that example. Okay. All right, for number 4, it says write the standard equation of a circle. The point 4, 7 is on the circle with a center of 9, 12. So this is my H and K, but notice it does not give us a radius. It just says the point. Well, remember, just as I mentioned, it doesn't matter where that point's at, okay, it is still the radius from that distance. But in this case, we don't know that exact distance without using something that you did in GAC 1, which is the distance formula. So I'm just going to write this out here for you. Okay, so you did use this in GAC 1. Okay, this is the distance formula. It's the distance from one point to the other. Okay, and so we are going to plug in our numbers here. So take the first coordinate point, x1, y1, plug it in, and take our second coordinate point and plug it in, and that's going to give us our radius. So this is really distance, but since we know that distance is actually the same as the radius in the circle, I'm going to change it to an r equals, and I'm going to start plugging numbers in. So my x1 is 4, my x2 is 9, my y1 is 7, my y2 is 12. Okay, and now I'm just going to solve for radius. So this would give me negative 5 squared. This would also give me negative 5 squared. Okay, so that is the square root of 25 plus 25, which is square root of 50. Now, usually I'd say simplify that radical, but because this is the radius, all right, then we don't really have to, because we're going to plug it back into the formula with our center at 9, 12. So we have x minus 9, quantity squared, plus y minus 12, quantity squared, equals our radius squared. Okay, so x minus 9 quantity squared plus y minus 12 quantity squared. And again, any radical times itself is just that number underneath. So this is just a simple 50. Done. Okay, last question here. The equation of a circle is x minus 2 squared plus y plus 3 squared equals 16. Graph the circle. Well, in order to graph the circle, you first have to understand what the center is. So as I mentioned earlier, the center, okay, is always opposite, but it's my h and k. Well, if this is negative, then it really becomes a positive. If this one is positive, then it becomes a negative. So my center is at 2, negative 3, and my radius is the square root of that number, because now we're working backwards. We're working from the equation to the graph. So that would be a 4. Okay, so I'm going to go on to my graph here. This graph goes by 2's. Okay, and I'm going to plot my center. My center is 2, negative 3. So 2, negative 3 is about right there. And it's got a radius of 4. So I'm going to go over to 6 from 2. I'm going to go over to 4 there. And then I'm going to go down to 4. Go up to 4. Okay, so I just listed all my points, and now I can draw my circle. And there you go. So that's how you write and draw an equation of a circle. You list your center, which is 2, negative 3, and then I've got a radius of 4. Okay? All right, so you got an exit ticket. Go ahead and try it out. Let me know if you have any questions. If so, I can try and look for some other alternative helpful videos. But again, today's lesson is all just about writing the equation of a circle. And it's right here one more time. It is x minus h, quantity squared, plus y minus k, quantity squared, equals r squared, where h and k is the center, and r is radius. Okay, give it a shot, and I'll see you.